Welcome. Today, we're diving into a question that's right at the heart of all science. How do we actually measure the world around us? How much, how hot, how heavy? It all comes down to the tools we use. And we're going to focus on the two big players, analog and digital. And hey, for those of you studying, you're in luck. This whole explainer is designed to break down Syllabus Reference 4.1.2.2. So we're going to cover everything you need to know about using these analog and digital measuring devices in your science investigations.
Okay, so let's kick things off with a little measurement mystery. Picture this. You're in the lab. You put a sample on a classic analog scale, and the needle lands somewhere around, about 200 grams. But then you take that same sample and pop it on a slick new digital scale, and it flashes 201.3 grams. So, which one do you trust? Which one's actually right? That's the puzzle we're going to solve today.
To get to the bottom of this, here's our game plan. We'll start with a tale of two scales to really get the fundamental difference. Then we'll build our investigator's toolkit with some key scientific concepts. After that, we'll figure out how to choose your instrument. And finally, we'll deliver the verdict on why the right tool matters.
All right, Section 1, a tale of two scales. Let's meet our two main suspects here and really understand the fundamental difference in how they operate.
So first up, the classic analog device. Think of a clock with actual hands, an old-school mercury thermometer, or the speedometer in an older car. These instruments use a continuous physical scale, like a needle on a dial or a column of liquid, that moves to show you a measurement. The key thing is, you have to interpret where that marker is sitting on the scale.
And on the other side of the ring, we've got the digital device. This is your smartphone stopwatch, a digital kitchen scale, you name it. Instead of a moving part on a scale, it just gives you the answer. It's a clean, direct number on a screen. There's no interpretation needed, just a clear, discrete value.
Now, to figure out which of our scales we should trust, just knowing what they are isn't enough. We need the right concepts. So let's open up our investigator's toolkit and get fluent in the language of measurement. First tool in the kit, accuracy. It's really simple. Accuracy is all about correctness. How close is your measurement to the real, true value? The easiest way to think about it is like a dartboard. Accuracy is how close you get to hitting that bullseye. Next up, we have sensitivity. This is all about the level of detail an instrument can give you. What is the absolute smallest change it can actually notice and show you? So a scale that only measures in whole grams is way less sensitive than one that can measure down to a tenth or even a hundredth of a gram. And finally, in our toolkit, we have range. This one's pretty straightforward. It's the full scope of what an instrument is built to measure, from its lowest possible reading to its absolute highest. I mean, you wouldn't use a delicate kitchen scale that maxes out at 5 kilos to weigh a car, right? Of course not. That car is way, way outside the scale's range. Okay, check this out, because this slide is a perfect example of sensitivity in action. Imagine we're measuring boiling water. The analog thermometer, it reads a perfect 100 degrees Celsius. Looks great. But the digital one? It reads 99.8. So why the difference? It's because the digital thermometer is more sensitive. It can detect and show you those tiny fractional differences that the analog scale just kind of rounds off.
All right, now we have our toolkit, accuracy, sensitivity, and range. So let's bring our analog and digital devices back for the showdown. It is time to choose our instrument.
Okay, let's look at this head-to-head. With analog, you're stuck interpreting a scale, which opens the door for human error. The big one is called parallax error. That's when the reading looks different just depending on the angle you're looking at it from. Digital devices, they totally eliminate that risk. They just give you a number. They're also usually more sensitive. But, and this is a big but, there's a trade-off. Analog tools are often mechanically simpler and more durable, while digital gadgets need batteries and can have electronic glitches. So, here's the crucial point. A good scientist doesn't just grab the closest tool. They actually follow a logical process. First, you define your need. How precise, how sensitive does this measurement really need to be? Then, you estimate the range. What kinds of values am I expecting to see? And finally, you assess the risks. Is this an experiment where one tiny little human reading error could mess up all my results? And that brings us to the end of our investigation. After looking at all the evidence, after weighing all the pros and cons, what's the verdict on our little mystery of the two scales?
And the verdict is this. It was never about which scale was right or wrong or which one was better. The real answer, the scientific answer, is that it's all about which instrument is the most appropriate for the specific job you're doing. For a quick estimate, that analog scale might be perfectly fine, but for high-precision chemistry, that digital scale is absolutely essential. The real skill is knowing which one to choose and when. And this brings us right to the core lesson from the syllabus. This is the ultimate takeaway. A great scientist doesn't just pick a side in the analog versus digital debate. No, they know how to use both. They know how to compare their range, their sensitivity, and their accuracy to get the best possible data and improve the quality of their observations. So, I'll leave you with a final thought to take with you. Now that you're armed with all this knowledge, I want you to look around. At the gas pump, in your kitchen, on your car's dashboard. What everyday measurements are you going to see differently now that you can think like a scientist?